So let's talk about how do you access normally a storage. Now this is irrespective of whether you are working for a Oracle real application cluster. This is just a generic understanding as to how one could access storage either in a NAS mode using NFS or in a SAN mode using LUNs. So let's first try to understand this diagram. I am talking with respect to a NetApp filer, where a NetApp filer can function both as a NAS or as a SAN. So here is my storage. This is, I assume, is my NetApp filer. It works in both modes. As I said, it can work as a NAS, network attached storage, or a SAN, a storage area network. Now in a NAS mode, if somebody configures this, it gives you an ability to create volumes. If you configure the same thing in a SAN mode, it gives you an ability to create raw LUNs. Now when we talk about in a NAS mode about a volume, we make these volumes available to the respective nodes using NFS. NFS is a network file system. NFS provides you file level IO. So here on the node, the Unix server itself, I have either a regular network interface card, or I have a 10 gigabit Ethernet NIC, or I have an iSCSI HBA. So this rectangle here indicates on the server you have either of the three items available here. Either it's a regular NIC card, or it's a 10 gigabit Ethernet NIC, or it's a iSCSI HBA. Now to overcome the network bottlenecks, we have implemented here a 10 gigabit Ethernet. So I assume you are using a faster network. This is not always that you need a faster network for accessing a storage. You can also implement a regular gigabit Ethernet. But in a true production sense, you would surely not be using a gigabit Ethernet. A gigabit Ethernet will have bandwidth limitations, which a 10 GB will always overcome. Now let's understand what is the purpose of this regular NIC. So I assume on the server we have a regular gigabit Ethernet card, a NIC. So this NIC will have its own TCP IP address. How does this access then my volume in a NAS mode or a raw LUN in a SAN mode? If it's like a volume, your NIC has a TCP IP address, the volume can be directly mounted using NFS onto the respective servers. So we are internally using NFS way of working, which provides you a file level IO. So I would log on to the server, will provide the IP address of my filer and the volume name, and the volume can then be mounted over a NFS. Same also applies if I am using a 10 gigabit Ethernet. The only difference would be the speed. Now instead of a regular NIC, I am using a 10 gigabit Ethernet, but again I am creating on the NAS a volume which gets mounted using NFS onto the target servers. However, as I said, you can use a cheaper technology to treat that your NetApp works as a SAN by creating raw LUNs. Now assume that I am using a regular network here, a gigabit Ethernet. How do I access these raw LUNs? There are two ways. Either instead of a regular NIC, implement iSCSI HBA. Now iSCSI HBA works as an initiator software. Now this initiator helps me to access the raw LUNs from the target host. So I can directly access a raw LUN. We'll see what exactly it uses. Or if you use a regular NIC which does not have a built-in iSCSI initiator required to get access to those raw LUNs, then you will need a software called as a ISCSI initiator software. So if you are using regular NIC, use a ISCSI initiator software. If you are using a ISCSI HBA hardware, then the initiator is built into the hardware itself. So both ways those raw LUNs can be accessed. For NFS, there is nothing required in special. It's just a TCP IP address, and your storage will be directly mounted to the target nodes using network file system. Now when we talk about a regular NIC, I told you that you need a ISCSI initiator software on the target machine. So I must have a ISCSI initiator software, and this ISCSI initiator software provides you, which I didn't draw in this diagram. Let me draw it now. So if I am using I would need a ISCSI initiator. This initiator, as I said, is used to access your storage. This initiator could either be a software or could be a hardware. So if it's a regular NIC you are using to access storage, ISCSI initiator would be a software. If you are using a ISCSI HBA, that ISCSI HBA can itself function as an initiator. Now the job of initiator here is to access these raw LUNs. Now each initiator would have a unique ID called as IQN number. So each initiator would have an IQN number. A NIC regularly has a MAC address. So an initiator also has to have some address. That address is called as IQN number. So what we do while configuring, we go on to the storage. So I would go on to this storage. I will configure a raw LUN. Now this raw LUN needs to be mapped to the target server. So the target server must have its own identity. That identity is nothing but the IQN number. So I can restrict this raw LUN to be accessed from this host and this host only. For this I would need an IQN number. So I would map that LUN to a specific IQN number. Now that LUN can no longer be accessed from any third machine until I map it to a given server. Clear? Now when it comes to a volume can be generically mounted from any machine. So I can go to a regular etc exports file, mention the IP address of the target servers from where this NFS volume could be mounted. Then I log on to the target servers and get this volume mounted. If third server which is not in my IP address list try to mount this same volume, it will not be able to do so, because I have done a hard-coded mapping via etc export saying only TCP IP address X and Y should be able to access my volume. A similar thing we are trying to do it on a LUN level by using the IQN number. Clear? So understand this one more time. So if this is NIC, regular gigabit Ethernet NIC, I would need a software. That software would work as a ISCSI initiator. ISCSI initiator is required to access a LUN on a regular Ethernet. Clear? If I am using a 10 gigabit Ethernet, I can still do though, the only difference would be the speed would be better. If I am using ISCSI HBA, then I don't need a software, because ISCSI HBA itself has a built-in ISCSI initiator, although it will also have its own unique IQN number. Clear? So in case of a regular NIC, IQN is provided to you by a software-based ISCSI initiator. In case of a ISCSI HBA, the initiator's IQN number is provided by the hardware itself, and then you access the raw LUN. This is the cheapest of the options available to you. Obviously, you would be suffering using the regular network speed. So if I am using the network here as a regular gigabit Ethernet, then obviously I am limited with the speed. If I am using a 10 gigabit Ethernet, speed is good, but then the implementation becomes costly. Assume that I want to try a storage at home. What I need? I need a NetApp filer storage, either in a form of a physical NetApp filer or a simulated one. Then I need two machines. I need a regular gigabit Ethernet switch and I need regular NICs. Now to have those regular NICs access my LUNs, which I create on my NetApp filer, I would need iSCSI Initiator software. That iSCSI Initiator software is available as a freeware almost on all platforms. Once I have that iSCSI Initiator software, will allow me to create one IQN number. Then I can map that LUN to a given IQN number. Once that is mapped, I can do the discovery of that LUN. I can start using them. If it is NFS is quite straightforward. You don't need anything beyond TCP IP addresses. So I would have a TCP IP address of node 1. I would have a TCP IP address for node 2. And I would have a TCP IP address for my NAS. And then I can export those volumes, get it mounted using a regular NFS protocol. This is how you could implement a cheaper NAS or a SAN. 10 gigabit Ethernet is for production purpose, not for a home environment where you would like to do a proof of concept. Understand the difference? NFS allows you a file level I/O, while a LUN gives you a raw block level I/O. Clear? So this is how one could use it in real life. However, the more prominent usage is this model, where you use a SAN. On a SAN, you would create a raw LUN. Using a fiber technology, you will have a fiber switch in between. And on the machines, you no longer use NIC or 10 gigabit Ethernet, or you don't use iSCSI HBA. Instead, you use fiber channel HBA. iSCSI Initiator gives you a unique address. I said, if it's a software provides you IQN. If it's a iSCSI HBA, the IQN number is built into that HBA itself, which is a hardware. Similar way, in case of a fiber implementation, each host would have a FC HBA, fiber channel HBA, and the fiber channel HBA, like a MAC address, will also have its own unique address, and that the address is called in this case as a WWN number. Clear? Again, I go back to my storage and map this LUN to a given WWN number. So that LUN can only be accessed from that server. Clear? This is how people do it in production usage, where SAN is more prominent than a NAS. But now, given that the technology has improved beyond a gigabit Ethernet, now we are in a 10 GBE environment. Now NAS or SAN really doesn't make any difference, because access speed is no longer constrained by your gigabit Ethernet. Now we have 10 gigabit Ethernet. So speed while accessing the SAN or a NAS for that matter is no longer limited. Now your NAS can perform equally good compared to a SAN. I would say it can outperform a SAN, because a NAS comes with a 10 gigabit Ethernet, while a SAN is still being accessed using a technology 4 Gbps access using fiber channel HBA. So this is how you access it in real life. So whether you use it SAN, you have to decide iSCSI or FCP. If it is iSCSI, you have a benefit. For a proof of concept, you can use regular network. For a production, you will use 10 gigabit Ethernet. With FCP, obviously this is not an environment called as a home playground. You cannot implement a FCP just for a proof of concept for your home trials. It's truly a production environment. So iSCSI either can be implemented using a software initiator or could be implemented using a hardware HBA. In both the cases, it will give you a IQN number. IQN is required for learn mapping. Clear? Now, I am going to show you a quick demo. Here, I have a NetApp filer. This NetApp filer has 25 disks added so far, but does not have any other storage aggregation created. It is just having a disk, nothing more has been done on this one. Now to configure your NetApp, we already have seen in another video how to make it work as a NAS. Here we create a volume and then we export those volume to the target host. Here we are going to see how you can make use of a NetApp filer using a regular iSCSI to create raw LUNs and then mapping those raw LUNs to the target host. I told you that your target host would either need regular NIC or it would need a iSCSI HBA. What I have on the target host is a regular NIC. If I have a regular NIC, to get a IQN number, I need a iSCSI software, initiator software. So let's see whether we have that iSCSI initiator software installed on the target host. If it's a iSCSI HBA, software is not required. Obviously, a hardware iSCSI HBA would perform a lot better than a software iSCSI initiator using a regular NIC. Reason, when I receive a TCP IP packet, we need to decapsulate it, removing the various layers and then extracting the data. It requires me to use CPU to do this task. So my machine, depending on the input of packets, would be burdened because my CPU needs to decipher those packets. If I have used iSCSI HBA, the iSCSI HBA has an engine called as, that engine is called as TOE engine for TCP offload engine. Is what it does the necessary deciphering of the packet on the server side at a iSCSI HBA level. So your CPU does not have to work on deciphering those packets. Clear? So the advantage of you using a iSCSI HBA is it comes with a built-in iSCSI initiator and it has a TCP offload engine. In a software-based implementation, if I use a NIC, the necessary job of providing iSCSI initiator IQN number is being done by a software and TCP offloading is being done by your CPU. So it's not a true product. In a true production environment, it doesn't make any sense to additionally burden your CPU with the TCP offload part. So just to quickly sum up, if I use iSCSI HBA, the iSCSI HBA provides IQN number. When I say iSCSI HBA, I am talking of a hardware and has a built-in TCP offload engine. If you don't want to implement, if you don't want to spend money on buying a iSCSI HBA, you can buy a regular gigabit NIC, which is also a hardware. it cannot function as a iSCSI initiator. Use some iSCSI initiator software. In this case, the CPU would be burdened because those TCP/IP packet deciphering job has to be done by your CPU now. Earlier, if you use a hardware, that job would be done by your hardware itself. In either cases, you can still create LUNs on a NetApp, then access these LUNs using iSCSI. So now here we have a NetApp filer storage available to us. So far nothing has been done, as I said earlier. Let's check what is the IP address of your NetApp filer. The IP address of my NetApp filer is this one. I try to access this filer using a browser to show you that so far there's nothing being done on the filer side. So here I am. This is my NetApp filer. I go to storage, disks and manage. You have those 25 disks which are not being used. All of them are showing as spare. Predefined aggregate AGGR0 would exist. Nothing has been done beyond this. And predefined volume would exist, indicating there has been no work done so far on the NetApp filer. So everything needs to be set up afresh. I am closing this one. Next thing is to log on to a Unix host and ensure, so we are going to use this model. I do not have a iSCSI HBA hardware. Instead, we will make use of a regular gigabit Ethernet NIC, and then we will ensure that our machine has a necessary iSCSI initiator software installed. We will determine what is our IQN number, then we will go back to the storage, and then we will configure that storage and we will try to map a LUN with a given IQN number. Clear? So here I am on one of the machines. First thing is to check whether I have my network in place. So we have two network cards attached to this machine. I am going to make use of any one of them for accessing the iSCSI LUNs. So second thing is I have NIC in place. I need to ensure that I have necessary iSCSI initiator software installed. So I log on here and then I say rpm-qa grep-i iSCSI. You see that there's a software installed called as iSCSI initiator. It's already there. Microsoft also has a iSCSI initiator software which you can download and install. Let me see if I have one. You see here the highlighted item. I have a Microsoft iSCSI initiator. I'm trying to launch it. So here also Microsoft iSCSI initiator is a software. Clear? So here I can do discovery. I can check what all targets LUNs are available and so on. A similar concept on Linux also exists. I have installed on a Linux iSCSI initiator software. This is required because I am not using iSCSI HBA. I am using a regular NIC to access a LUN. would require a IQN number. The IQN number is provided by iSCSI initiator. So once I have this iSCSI initiator, I would check what is my IQN number. So I am checking it via etc initiator name.iSCSI, and this is the format of your IQN number. So I have IQN, some name and some identifier. I would log into another machine. This is my second rack node. This is my IQN number of alpha. Then I have beta. And then I have gamma. So for all three nodes, you will see that the IQN number is unique. Rest other things may be same. What I deliberately kept as different is this one. If you think this is too fuzzy to understand, you could have changed this to something like to a more meaningful naming convention. Instead of using those randomly generated numbers, I am using a more meaningful names here. Why these are more meaningful names? Because when you try to access or learn from a NetApp, it will try to log in, and at the time of login, the NetApp log will show who has logged in. If I use a name of this fashion, I have to rely on my numbering skills. If I use this naming convention, I can quickly figure out that somebody has tried to log in using the iSCSI initiator from a host name alpha. Either way it's okay. Either naming, numbering, which gives a unique IQN number, or via a unique naming style. So some way you need to have a unique IQN number per host. We have it already in place. Next thing, now that I have determined I have necessary things in place, I have a gigabit NIC, I have iSCSI initiator software installed, and each iSCSI initiator software has given me a machine specific IQN name. Okay? This IQN name is required to map a LUN on the storage side. Then I jump onto my storage, and here I start creating aggregate, volumes and LUNs. In our initial video, we have already talked about how to create an aggregate and a volume. I am going to run through pretty much the same steps. What is additional here is, we never did a LUN setup earlier. Now that LUN setup I am going to do now. So first let's check what we have. We have already determined that on the Linux server we have the necessary iSCSI initiator. Now on the Linux server, so that it discovers my SAN, we must provide in iSCSI.conf file the IP address of your filer. Remember that the IP address of your filer is this one. So I go to each of these hosts and I edit the file iSCSI.conf and I put in the proper discovery address. This is the only mandatory setting, by the way. All others are pretty much at the default level. Here, this IP address is the IP address of my storage. I do pretty much the same thing on each of the machines. There is no discovery address, I believe, mentioned here in this case. I need to type in. So I mentioned the discovery address for all of them. This is my iSCSI configuration on the target servers. Okay, my servers are ready to access the given storage, but the storage itself is not yet ready. So I log on to NetApp and then I try to create an aggregate. Before I do this, let's check what is there. So far there is only one aggregate named AGGR0. I am going to create a new aggregate. So I am going to say aggregate create AGGR and with the number of disks. I have 25 spare disks which I would like to give to this aggregate. Now I say AGGR status one more time. Here you can see now a new aggregate got created with red level core protection. Clear? By default, those aggregates allow you to take a snapshot. So I am looking into specifics of aggregate 1. This is how my aggregate 1 looks like. By default, snapshot feature is enabled on all aggregates in NetApp. Having that snapshot feature means there are more disk overheads. The disk space cannot be utilized to its fullest extent because it reserves that space for storing snapshot. To improve the performance, if you don't plan to use snapshot feature, let's disable it. So I am going to disable a snapshot feature. Not mandatory, but as I said, it improves the performance. So earlier it was not showing any option here. Now it says I don't want to have the facility to take a snapshot on this aggregate. Next thing is, let's create a volume called as volume 1 in aggregate 1 of some size. So I said volume create, volume 1 is the name of my volume, aggregate 1 is the name of my aggregate, and what size you would like to be. Give it for this particular volume. I am creating a 17 GB volume. So it says creation of volume vol 1 with size 17 GB on the containing aggregate 1 has completed. Now you can see we have successfully created a volume. Now we will try to do a setup of LUN. Clear? So now I go and say LUN setup. Here I go. Then I say LUN setup. It says, do you want to create a LUN? Yes. It says multi-protocol type of a LUN for which operating system? Solaris, Windows, HP Unix, AIX, Linux, or whatever. Our hosts are Linux based hosts. So I am selecting the default option of Linux. It says tell me what would be the path of your LUN. Coming back to our requirement. How many LUNs do you need? I would need LUN 0 for storing a OCR. I would need LUN 1 for storing a voting disk. I would need LUN 2 for ASM 1, LUN 3 for ASM 2. Depending on your requirement, you will have to create multiple LUNs. If you want to store normal redundancy OCR, you would need 2 LUNs for OCR. If you want a normal redundancy for voting disk, you would need 3 LUNs. Depending on your ASM requirement, you would need multiple ASM LUNs. So you will have to create those many LUNs here. Here. So I don't want to demonstrate a high redundancy for your OCR or for your voting disk, because the process is tedious for creating a LUN. I don't want to repeat that same thing again in the video. Depending on that, this approach, you can create as many LUNs as you want. So for my OCR, I am going to create a 200M LUN. For my voting disk, I am going to create a 200M LUN. Here for ASM purpose, I am going to create 3 LUNs of 5 GB each. Clear? So let's create them. Back to my wizard for LUN setup. It says enter the LUN path. So I am saying this is my LUN 0 under volume 1. Remember, we create an aggregate. Within that aggregate we created one volume, and now within that volume you are creating LUNs. I am going to create 5 LUNs. One for OCR, one for voting disk, 3 for ASM purpose. It says, do you want it to be a space reserved? So I want to reserve that space. Tell me what is the LUN size. I want it to be of 200 MB. Any comment that you would like to give it for this one? So I am saying raw LUN for OCR. Good enough? It says, tell me what is the initiator group name. This is the first time setup. So it is asking you any common name for that initiator group itself. I am giving a common name as Aura. It says, tell me how you plan to access this LUN. Using fiber channel protocol or using even a cheaper one, iSCSI. iSCSI, remember, does not require any special purpose devices. I can make use of a regular LAN and still I can access a raw LUN using iSCSI protocol. Obviously my choice is iSCSI. It says, tell me from which node you would like to access this LUN. This is what I said is a mapping of a LUN. Now it requires you to mention IQN numbers of the target host. Now I am going to copy IQN number of alpha, IQN number of beta, IQN number of gamma. Once done, I am saying blank. It says the initiator group has an associated operating system type. The following are currently supported: Solaris, Windows, HP, Unix, AIX, Linux, NetWare or VMware. Which OS type you want to use for this initiator group? You want to use for Linux. It says the OS, the LUN will be accessible to all the initiators in the initiator group. Enter question mark to display LUNs already in use by one or more of this SCSI initiator. LUN ID at which this initiator group Aura sees this LUN is 0. Yes. This is the LUN summary. This is what we have set up. Volume 1 LUN 0 of 200 MB. This was the name that you gave for the initiator group called as Aura of the type iSCSI, and these are the members from which you could access the given LUN. Clear? Similarly, I will create a 200 M LUN for voting purpose, and then I will create 3 LUNs of 5 GB each to be consumed as ASM. It says, do you want to accept this configuration? Yes. It says, do you want to create another LUN? Yes. For the operating system, Linux, the LUN path would be LUN 1. It should be a space reserved one of the size 200 MB. Comment string raw LUN for vote disk. Initiator group that it is part of is Aura. Remember, we created an initiator group in the first case. It says LUN ID at which the initiator group Aura sees is 1. Yes. Do you want to accept it? Yes. It says, do you want to create any more LUNs? I said yes. For the type Linux, LUN path would be it should be a space reserved one. It should be of the size 5G. I said raw LUN for ASM disk 1. In the initiator group called as Aura, I am happy with the LUN mapping. I am confirming this. I want to create one more for the Linux. LUN path has LUN3 space reserved of the size 5 GB. Comment string ASM disk 2 for initiator group called as Aura. I am happy mapping it to LUN3. Last one, Linux LUN4 space reserved 5 GB. It says you cannot go for a 5 GB one, that much space is not there. Maximum I can go is for this much. I am going for the size. It says what is the name for this one. I want to give as a comment, whatever. It says name of the initiator group that it is part of 4. Are you happy? Yes. Do you want to create another LUN? No. So all those LUNs are created. Now to access this one on iSCSI, there are two concepts. On the storage side and on the server side, which is our client. Here I said you have something called as similar way. On the storage side you have something called as so storage needs to have iSCSI target and client needs to have iSCSI initiator. We have done necessary things for iSCSI initiator on the server side. What we haven't ensured, whether my NetApp itself provides me iSCSI target. So that for this one, let's check whether we have iSCSI service. It says iSCSI service is not running. I will have to start it. Then I check the status. Now it is running. Now we have this NetApp filer available as a SAN with all those LUNs. Let me see what LUNs we have. I say LUN show, and these are the LUNs that we create. Clear? Next thing is, how am I going to access them from the target machine? So storage part is done. Keep a watch on what messages I get to see on the storage side. Remember in etc iSCSI conf, you have mentioned the discovery address. This is nothing but the IP address of your NetApp storage. Clear? So necessary things are there in place. The only thing is now remaining is restart the iSCSI initiator service on the client. So I need to know what is the service name first. This is the name of the service. So far it is, after those configuration changes, we never started it. So I am going to start this service. It says starting iSCSI service. It says cannot make connection to something. I believe it's still picking up a wrong IP address, isn't it? Ours is not the this IP address. So I am going to check why it is still picking up a wrong IP. And this is the reason why it was picking up a wrong IP. Somewhere above, the old IP was still there. But below, we have given a correct IP address. I said after making those changes, restart it. See what it shows on the NetApp filer side. New session from initiator. So and so. Remember there is a 01 and 01 was for whom? Alpha. This indicates alpha is now trying to access those LUNs. So that IPN number, whatever you give it, whatever naming style, should tell you where from the person is trying to access it. On the storage, I get to see that somebody is trying to access it from 172.168.5.160. This is nothing but the IP address of your alpha host. Clear? Similar thing I would try to do from beta. Before I do that, did I receive all those disks? I am saying fdisk -l. Dev SDB is of 200 MB. Does not contain any partition, means it's raw. Dev SDC is of 200 MB. Does not contain any partition, means it's raw. SDD and SDE both does not contain any partition and is of 5 GB each. SDF also does not contain any partition, meaning it's raw. Remember, this is the size we gave for the last LUN. It was not of full 5 GB. Clear? So those disks are accessible to me. So to my machine, it appears as if it's a local device. But is this a local device? No, it's coming from the storage. It's raw and visible to my machine as if it's a local storage. It's not local. Everything that I store on this device going further now is going to my storage. Clear? I must do the SCSI startup for beta and gamma as well. Here it looks okay, so I am going to start. Before I start, let me show you what disks are there. This is the only disk before the start of ISCSI initiator service. Only when I restart it, it will try to discover those LUNs and will show them as if they are local devices. Now I am saying service ISCSI. Also again it's trying to log on to a wrong host, looks like. So let's revise if this IP address is still there in that SCSI conf. I checked it manually though I couldn't locate. Not there. So let me restart. See here. Now it says somebody is trying to log in from beta. This message 02 is for beta. Now I say again fdisk -l. You can see all those devices. So all these disks are again not local to beta. Then I log on to gamma and do the same thing there. You can see there's a third session now open for those same storage. Once we are done, we should be able to query those disks from Gamma as well. You can see all those disks. None of the disk has a partition so far. I am logged into Alpha one more time. Now I'm trying to prepare those disks for our access from SDB to SDF. All of them are block devices. I will have to create one partition each and then do a raw mapping. So I am going to create one partition each into SDB. I said SDD anyways. New primary partition, partition 1, starting ending cylinder number, save and quit. I will do it same way for B, C, E and F. To prove that these are shared disks, I am going to do fdisk-l of /dev/sdd. Until now, remember that what it says. SDD does not contain a valid partition. But from alpha now you created one partition into it. See, you can see this partition from here. This proves the point that it's a shared disk. Anyways, I am going to go through the partitioning of every other disk. New partition, primary, partition 1, starting ending cylinder number, save and quit. Now I am doing it for C, new partition, primary partition, first partition, starting ending cylinder number, save and quit. Now doing it for E, D was already done. Save and quit. Lastly, for F. So that my new devices are detected, I am saying part probe /dev/sdb to F. I will do the same thing on gamma. I will also do the same thing on beta. Now let's see how those devices look like. Earlier it was without one. Now there's a one new device that is nothing but the name of the partition. Now let's map this device to raw device equivalents. It's already there. Raw 1, raw 2, raw 3, raw 4, raw 5. I'm going to do pretty much the same thing on beta and gamma as well. I say service raw devices restart, then I check whether my raw devices are there or not. Here, those raw devices are there. I must do the same thing on beta. I check whether those devices are there or not. I change the ownership on all those raw devices so they are accessible by Oracle. I'm back onto alpha. I do the same setup here as well. I change the ownership on those devices. Here, this is how you access the storage. Now, whatever you put on this storage is actually being stored onto your NetApp using a ASCII protocol, using a regular gigabit Ethernet. Let's do a quick test of it, and then probably we can get going about our understanding. Here I am onto the filer. I am logging one more time to see what has changed after installation. I go to learn manage. These are those LUNs that we created. Remember last time, the last LUN that I wanted to create, accidentally I typed 3 there. That's why those description doesn't show a correct description. This is the LUN statistics as to how much operation has been done so far on them. The initiator groups that we created, Aura was having the IQN number of all the target 3 servers. This was on the storage side. I am coming out. Now I log on to alpha. I go to the clusterware folder. Presumably all other things are there in place. Just to ensure I am doing a cluster verification. Those nodes are reachable. It's now checking the user equivalence between all the users on all the nodes. It says user equivalence has failed between alpha, beta and gamma. Let's check why. I can let's do it vice versa. Yeah, this is also working. Let's try to do it from gamma. Once done, let's rerun the test. Now everything has come out cleanly. Sounds good? Let's start the installation. Added all 3 nodes. It has automatically detected because the subnet masks are different, public and private IP addresses or interfaces. Here it says now, tell me where you want to store your OCR. Remember now my OCR is clear. Remember my voting disk is now raw too. So it's going this installation now on those 3 nodes. We want to see how we consume those raw devices at the end. There's no fun watching this progress bar go from 1 to 100. I'm putting a pause on this video. Understood so far? We went to the storage, we create an aggregate. Within an aggregate, we create a volume. And within that volume, we created LUNs. Then we mapped those LUNs to the given host using the IQN number of those hosts. In real life, people map the LUN using WWN number. WWN number is a FCP topology. When you have a fiber channel HBA on the server, each server will like a MAC address. That HBA card will have its unique WWN number. They go on the storage, they create a LUN, and then they say this LUN is only visible from this and this host. They type in the WWN. That's it. As कभी में WWN की जगह IQN बोला जाए. Because it's a shared device. मशीन को देखते वक्त ऐसा लग रहा है कि उसका लोकल डिस्क है. It's not local. Everything that you store now on this dev raw one is actually going on the storage. Part probe is otherwise reboot करना पड़ता था मशीन. कभी भी डिस्क में पार्टीशन होने के बाद में अभी तक मेरा डिस्क का नाम था /dev/sdb. उसमें पार्टीशन किया तो उसका डिवाइस नाम बनेगा sdb1. वो बनने के लिए या तो आप रिबूट करो या फिर पार्ट प्रोब करो. So it rereads the partition table on the disk and then creates a suitable device name. In our case, the device name was dev SDT1. So the installation of the cluster software is done. It's asking me to run orinst root.sh on alpha, beta and gamma. Here I am on to alpha. Then it is asking me to run root.sh from CRS home. Now notice which devices it formats. It's formatting the voting disk, which in our case is a raw device. Remember, this raw device is coming from our storage. Here I go on to the storage. I would try to go through using the web interface. That way I don't have to type much. Here I am on the filer view. Now you will see these statistics about the number of data input output which will be changing. Which LUN we are formatting now? That's why you see higher number of read write operations for your voting disk. Voting disk is our second LUN. So it says the formatting of that raw device is done. Now the services would be queued in your init. It is going to add those 3 entries to your init tab, and later it is going to start up the services. Similar script, I need to run it on beta and then on gamma as well. Now it says adding daemons to init tab, expecting the CRS daemon to be up within 600 seconds. The statistics will keep on changing now. See, you see some IO also happening now on LUN 0, which is our OCR. That's done on alpha. Now I am going to run the same thing on beta. No more formatting of voting disk now. Once the same script runs successfully on beta, you will have to do it on to gamma. So this will indicate, once we have done this installation, we will see where our OCR is, where our voting disk is, and these are nothing but they are the raw LUNs coming over ISC to your target host from a NetApp storage. So it's all done on to beta as well now. Let's run it on the last node. While it is doing something out there, I am saying OCR check. See where the OCR is? On dev raw 1. And my voting disk is on to dev raw 2. Once we have necessary things in place, we should see all the services are up and running. Now this is running on the last node. Remember that on the last node it also invokes vipka to configure the virtual IP addresses. Until now it is used to fail, but now there is no reason for it to fail because all IP addresses are from proper classes, proper subnet groups. So it automatically has identified which NIC is public and which one is private. So everything should come up cleanly in this case. Now it says running VIPCA in a silent mode. Now since those IP addresses or the NIC are from proper subnet, it should come up cleanly. So all looks to have completed without any problem. Let's validate it from node 1. Here is a 3-node cluster setup. So this was all about our understanding of NAS or a SAN. To quickly summarize, we have discussed how to use iSCSI, either using a iSCSI HBA or using a gigabit Ethernet. What is the function of a iSCSI initiator and the IQN number, and then we did a setup on a NetApp filer to function as a SAN where we created LUNs and those LUNs were accessed from the target servers using iSCSI. That's it for this session.